Hi guys, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and today I'm going to solve a hybrid Sudoku variant. This Sudoku was created by Ecos, an author whose Sudokus we haven't covered previously on the channel. The link to solve this Sudoku is given in the description of the video. Do give it a try, seems to be a really interesting one. So having said that, let us have a look at the rules of the Sudoku now. Normal rules apply. Each row, each column and 3 by 3 box will have digits from 1 to 9. And then you have palindrome rules. So you can see some gray lines on the grid, right? So these lines are palindrome lines, meaning they read the same from both the directions. So for example, if you have a 2 here, then this end of the palindrome must also have a 2. And similarly, the second cell from this end, if it's a 3, let's say, then the second cell from the other end must also be a 3. So this is how a palindrome works. Of course, a palindrome may also be having a length of 5, in which case the middle digit will not have a clone, right? It will be a solo digit, it will not have a clone. And then you have killer rules applying in the grid. As you can see, there are some dotted cages, right? So when you add those digits in the cages, you'll get the clue given at the top left corner of the cage, right? Killer rules apply. And then what do we have? We have crop key rules. So you can see some black dots. There are exactly 3 dots inside the grid. So these two cells which have a black dot between them will have a ratio of 1:2 in any order. Doesn't matter, but they'll have a ratio of 1:2, right? Just a second, I'll adjust the screen a bit. Okay. And the last part is that the negative constraints do not apply. So for example, you may have something like 3 and 6 adjacent without any black dot there. So this is perfectly applicable. There is no problem. So these are the rules. With that, we'll start solving this Sudoku now. So very quickly, we can say that the palindrome lines are not yet useful in and of by themselves. So we need to look at the killer part or even the black dots in row 2 maybe. So let us look at this 18 cage and this 18 cage together. So if you add them up, 18 plus 18 gives you 36. And in any row, column or box of a Sudoku, we know that the sum of the digits is 1 plus 2 plus up to 9. It gives you 45. So which means that these 3 cells must sum up to 9. Right? Let us remember that. And we also have 24 from these 6 cells, right? So which means that these 3 cells must sum up to 45 minus 24, which is 21. So these 3 cells sum up to 9 and these 3 cells sum up to 21. So that is quite interesting deduction if you ask me. So we know that when a 9 is made out of 3 cells or from 3 digits, the maximum digit that can come is a 6, right? So it can only be 1, 2, 3. Oops, let me use center pencil. 1, 2, 3 and 4, 5 and 6. If you have anything more than the 9 total cannot be satisfied. But for the 21 to work out, you cannot have 1, 2, 3 here, because then both of those cells must take 9 or more than 9. So which means that this cell can only be 4, 5 and 6, right? If it is a 6, this becomes 1, 2 and this becomes 7, 8. Okay, that is possible, but I don't think we can do anything further with that now. 2, 3, 8, 9. Okay. Let us stop there. Let us look at something else. So 6, I know that this cage is either 1 plus 5 or 2 plus 4. And 5 can never be part of a black dot because you need a 10. So 5 is removed, which removes the 1 from here. So if it is 1, 2 or 4, then this one can be 2, 1 or 4 or 8. Okay, so this must be 1, 2, 4 or 8. What else do I need to look at here? Negative constraints do not apply. We need to remember that. Okay, let us look at these cells, guys. I said earlier that the palindromes are not useful in and of themselves, but you can see that this is part of a cage, this palindrome cell, and even this cell is part of a cage. We know that 14 is either 5 plus 9 or 6 plus 8. So which means that the other end of the palindrome must be the same as this. So this is 5, 6, 8 and 9. But this is part of a 2-cell cage having 8 total. So 8, 9 gets removed here. 8, 9 gets removed here. And correspondingly 5, 6 gets removed here. So this is 5 plus 9 or 6 plus 8. And when you have a 5, this becomes 3. And when you have a 6, this becomes a 2. After this, let us see what is there in the Sudoku. So these 4 cells are, let me highlight those cells, are same as these 4 cells, right? Okay, one more cell got highlighted. And these 5 cells would be the same as these 5 cells. Is that giving anything by itself? Okay. The sum of these 4 cells now must be equal to the sum of these 4 cells, right? Because you can notice that in column 4, these 5 cells would be the same as these 5 cells in box 4. So which means that the rest of the cells in that column, because this column contains one set of digits from 1 to 9, and this box also contains one set of digits from 1 to 9, which means that these 4 digits, the cells which are not highlighted in this column, must be the same as these 4 digits, because the reds and the greens cancel out each other. So that may be useful, right? So if you look at this cell, it cannot be here, so it has to be here. It has to be the same as this one, right? Both of those cells must be same in value, because we just established that these 4 cells must be the same as these 4 cells, and due to classic we can be sure that this cell cannot be happening in this case, so both of these cells must be the same. And the digits in these 3 cells are distributed into these 3 cells in some order. Okay. And what can this be? This cannot be 4, anything more than 4, right? Or even anything more than or equal to 4. So if you have a 4 here, the minimum total becomes 5, but we know that this is minimum, okay, this is actually 9 in value. So which means that you cannot have 4 here. This must be 1, 2 or 3, which means that this must be 1, 2 or 3, but in an 11 cage, we can't have a 1. So that's not 1. So both of these become 2, 3, and that becomes 9 or 8. And if you look at this cell, can you have a 4 here? Same idea as this one. If you have 4 here, 4 plus 5 is minimum 9, and you can't satisfy these 3 cells. So which means that this cell must be 1, 2 or 3, can't be anything else. Okay, so these 5 cells, just like in column 4, you have 4 cells highlighted in red and green, which are the same as these 4 cells, and you have 2 sets of 1 to 9, column 6 and box 6. and the reds and the greens cancel out each other. So these 5 cells in blue must be going into these cells, right? These 5 cells in some order. And this cell in particular cannot go here, so it must go either here or here. So now I know that these 3 cells must add up to 18 because of this total that I have with me. Okay, there is an 8-9 pair here that may be interesting. Something is definitely going on here, guys. Okay, let me revisit this 21 total again. So if you have a 4 here, then these two cells must be an 8-9 pair to get to 21. If this is 5, then you need 16 more from the 5 cells, so this must be 7-9 then. And if you have 6, then we need 15 more from the cells, and because of the 6 it would be 7-8 again. So this can only be 7-8 7-8 and 9. Wow, this is really beautiful, guys. Really nice. The same idea we used in this column 4 and box 4. We are going to use in row 6 and box 8, right? So these 5 cells in green are the same as these 5 cells, right? And if you look at row 6, we have one set of digits from 1 to 9. And if you look at box 8, we have one set of digits from 1 to 9. The 5 cells in green cancel out the 5 cells in green, which means that the remaining 4 cells must be exactly the same as these 4 cells. I'll just highlight for better clarity. Let us say we highlight them in black. Yeah. So, which means that these black cells must be equal to the cells in orange, right? And now I'll remove the highlights. So now if you look at this cell in particular, it must be in these 4 cells. It cannot be into these 3 cells, which means that this must be 7, 8 and 9 because they must be equal. So I'm going to highlight them in blue. So that becomes 7, 8 or 9 now. And we know that you can't have 8 or 9 in a 2 cell 8 case. So that becomes 7 and that becomes 1. Superb. So that is 8 or 9. This Sudoku is really excellent in terms of the logic used. And now I know that 12 kg is the sum of these 3 cells, and which means the sum of these 3 cells must be equal to 12. Okay, I have 1 here, so that's not 1 and that's not 1, so 4 must go into one of these cells, because then if without a 4 this becomes 2, 8, and that is not going to work out because of the crop key dot. So if I have 2, 4 here, I can eliminate the 5 from here. Very interesting, guys. A really nice Sudoku. Just not we don't have strictly Sudoku part here. You have to expand your imagination and think a little bit on how the digits go, or how the rows and columns and these palindromes work. So I wouldn't say that this Sudoku is an easy one. Certainly it's challenging. Okay, look at this cell, guys. And we are basically seeing the same idea repeatedly over. So these 4 cells in row 4 and box 2 cancel out each other. We know that box 2 contains one set of 1 to 9 and row 4 contains one set of 1 to 9. When these cells cancel out each other, the remaining 5 cells that you see in row 4 must be exactly the same as these 5 cells, right? So which means that this cell can't go here, so it is either going here or here. This is something to remember. So if it is going here, so this must be 8 and 9, and of course this can't be a 9 because you have 1 here, that would give you a 1 here, so this must be 8, but it can also go here, so that's the problem. So I was just reading out my thoughts aloud there. These three cells sum up to 12. Okay. Okay, let us look at this 9 cage, guys. 9 has become interesting now. It cannot be 2 plus 7 or 4 plus 5. So this is either 1 plus 8 or 3 plus 6. Okay, now I can eliminate the 4 from here, right? Because if I have a 4 here, I can never make 21 from these 3 cells. That I should have noticed right after I placed the 7, but better late than never. So 4 can be removed from here, because we know that 24 from these 6 cells and this becomes 21. So when you have a 7 here, you cannot have 4 in these 2 cells. So that's 5 and 6, and this is 8 and 9. And now I can't have 2, 3 here. This is excellent, guys. An excellent Sudoku. Because if you have 2, 3 here, then the total becomes at least 10. But we know that these 3 cells must be 9. So I'll remove the 1 from there. So this is, sorry, I have to place the 1 there. Without the 1, it's not going to work out. This is a 1. And now I know that 1 cannot go here, 1 cannot go here, because the palindrome is not allowing that. So which means 1 is in these 3 cells. And I can remove the 1 from the red cells as well, because 1 is not here, right? So that's a 1 now. Superb. That becomes 8. A really beautiful Sudoku, guys. I'm really happy doing such Sudokus for a live solve in front of you guys. It's so much fun to do such live solves for you guys. So you have 1 and 8 here, and I get the 1 here now due to classic. You have 1 here, you have 1 here. So which means that the other end of the palindrome gets a 1, and that allows me to mark a 1 using classic into these cells. Okay, so look at this 7, guys. This is helping us now. We have placed 2 7s. So let me just place a corner pencil mark of 7 there. So we know that 7 is not here, right? 7 is not into these cells. So which basically means 7 cannot go into these 2 cells. So which means that I get a 7 here. For box 6, these are the only cells which can take a 7. And we know that the total is, how much is that? I can't see. It is 18. So we need 3 plus 8, 11 more from these 2 cells, right? Can I have a 9, 16, 2? Yeah. Can I have an 8? 8 is also possible. Basically everything seems possible. I can't have a 4, guys. This is superb. So if you have a 4 here, 4 plus 7 is 11, and you need one more 7 to get to 18. So 4 can be eliminated, and 4 is not here, so that gives me a 4 here. And this is also 18, right? So which means that 14 more from 2 cells. It's either 5 plus 9 or 6 plus 8. 5 plus 9 or 6 plus 8. Okay, superb, guys. That's really awesome. So we can use the common logic. If it's 4, 5 and 9, you get a 6 here. Suppose if you have a 4, 6 and 8, you get a 5 here. So what is the common thing between those? So both the cases, 5 and 6 gets used in these 4 cells. That's awesome, really. So which means that I can eliminate 5, 6 from these 3 cells. So this is 4, 5, 9 or 6 and 8, 4, 6, 8. So I can eliminate 5, 6 from these 3 cells. So now it's 2 and 9 or 3 and 8, right? Okay, that still gives us lots of possible options. Okay, let me just mark those in. So it's going to be either be 279 or we eliminated 5 and 6 or 387. Okay, so I marked all those. Okay, I got an 8 here, guys. I'm really sorry for this. That was really dumb from me. This 8 gives a 9 here, right? Straight deduction that we could mark much earlier. Really sorry for that. So that becomes 9, which means this becomes 2. And both these cells are equal, so that becomes 2 now. And now this is a 9 total, so that becomes 6. 6 plus 7 is 13, so this would have to be 8. We're getting digits now. Okay, 9 here gives an 8 here. Superb. So that gives 6 here. And because of the palindrome, we get a 6 here, and that gives a 2 here. Right? That was really a silly miss from me. So we got that. And because 6 is here, this is not 4, 6, and 8 anymore. So this would have to be 4, 5, and 9. Oops. It has to be 4, 5, and 9, right? And which means this is 3, 7, 8. 8 is not here. And because of the 8 here, we know that this can only be 2 and 4. And that is satisfying the crop key as well, right? And I know that 8 can't go here in the red cell because of classic, and that allows me to mark an 8 into one of these cells, and we have already marked a 1 because of this one, so which means that we have a 1 8 pair now there. And now to fill the box, this must be 3 and 7, right? And I can just reproduce them on the other end of the palindrome. So 7 is removed from that cell. And 1 and 8 gives a 1 and 8 here. That's really nice. And now I think basically we can use some arithmetic here in box 8. 12 you have here, and these 4 cells add up to 1 plus 8, 9, 15, 22, right? So 22 from these 4 cells and 12 from this 3 cells. So that gives you 34, which means these 2 cells must add up to 11, right? They can't be 3, 8, cannot be 5, 6, cannot be 4, 7. So it must be 2, 9. Superb, guys. So that becomes a 2, 9 now because this is a palindrome. I've just reproduced that here. So this is not a 2 anymore. That's a 4, and that's a 2, and that's a 4. Awesome, guys. That's really fun, right? This is such a fun Sudoku. So you have 2, 4, 9 here and 1, 6, 8 here. So we can complete the box. Oh, you have a bit of classic going on here. So that becomes a 5. It's not a 3. So that is a 3. And you have 4, 9 pair. So 9 here gives you a 4 here and a 9 here. So 1, 4, 8, 9, 2, 3, 7. So this basically means this is 5 and 6. And which means that these are 5 and 6. So I can remove the colors, right? They are not required anymore. I'm unable to drag my mouse for some reason. Oh, sorry guys, I've marked them in a different color. Ah, what is wrong? Okay, so 279, 168. This must be 3, 4, and 5, right? 6, 7, 8, 3, 4, 5. So this must be 1, 2, and 9. I don't know why these blue boxes are behaving in a weird way suddenly. Did I click something else? Not sure. 1219. 3, 5, 6, 7, 1, 2, 9. So this must be 4, 8, and you have a 4 here. So that must be an 8, and that must be a 4, right? So that 4 gives you a 7 here, which means this must be a 2. And that allows you to mark this pair 2 and 9. And now I think we can mark this, right? So there is only one possibility, 3 and 6. You can't have 1, 2, you cannot have 2, 4, you cannot have 4, 8. So this must be 3 and 6. That means I can quickly resolve box 2. 3, 7, 6, 5. That's not a 2 because of the 2 here. And that is not a 9 because of the 9. And now let me look at this. Can't be 3, 6, it can be 1, 2. Okay, lots of options are there. So this 9 removes the 9 from here. And that 8 gives me an 8 here and a 1 here. So which means I can use the palindrome to write in the digits. 8 and 9, 7. So 7, 3. So using classic, 7 in gives a 7 here. That gives a 7 here. So this is not a 7. So I have 6 in these two cells and 6 in these two cells. Now in column 9, I have only one cell left for the 6, and that is this cell, because in row 9 you have a 6. That becomes a 6. 2 allows me to put a 2 and a 9 here, and that is satisfying the palindrome as well. So 189 and 247, which means that remaining cells must be 3, 5, 6. 3 is here, so let me remove that. Okay, now I know for sure this is not okay, wait, there is an easier way to show you what goes there. 8 is in row 1, row 3, guys, so 8 must be in these 3 cells, but 8 in column 1 removes the 8 from that cell, so which means that this must be having an 8, and because of that 8 we get a 4 there. Nice one. So 3, 5, 6, 7, 4 and 8, so this must be 1, 2 or 9, and you have 2, 9 here, so that's a 1. No 1 there. Oops, sorry guys, that is not a 1. So that is a 2, 9 again, and 2 allows you to finish that row. And quickly we can just tidy up the digits there. 2, 4, 7, 8, 9, right? So 1, 3, 5, 6 are the remaining digits. You have 3, 6 here, so that allows you to lock a 3, 6 there, and a 1, 5 here. And you can just finish off row 1 now. 1, 5 and 6, so 3 and 6. So this must be 2, 5 for the box, right? Yeah, so 2 is here, so that's a 2, that's a 5, and that gives you a 6 here. 1, 3, 6, 8, 2, 5, 9. So this must be 4, 7. We're almost done, guys. So that gives you a 4 here and a 7 here. And which means that I can mark the 7 in this box. So that's a 3 or 8. And because of the palindrome, I can finish off this one. So that's a 5 and that's a 6. And which means I can complete this. So that's a 6, that's a 3, that's a 3, that's an 8. Superb. So only digit left is 3 here in column 9. So 1, 3, 6, 2, 4, 7. So we can quickly complete the box. So that's 8, that's 9, and that's 5. So 1, 2, 6, 3, 5, 7, right? So this is not a 5. What is this? This is not an 8. So 8 in column 1. Column 3 has only one cell left. So that's 8, that's 4. This must be 4, 9 for the column. I have a 9 here. So this must be 4 and that must be 9. Which means this is a 4, 5 pair, and that 4 gives a 4 here and a 5 here. 2, 4, 6, 7, 8. So 5 is here, so that gives 5 here. And we can complete this column now, complete this box. 4 is in these two cells, so that gives a 4. And that's a 5, and that's a 3. And last 3 digits are 1, 3 and 9. You have 1, 9 here, so that's a 3. That's a 1 and that's a 9. Right? And with that, we have completed this gorgeous construction by Echoes. A really excellent solve. The start logic was utterly awesome, utterly delightful. We had lots of things to see in the Sudoku. It was not such an easy one, but definitely not too hard either. A really fun Sudoku by Echoes, thank you to the author for creating this Sudoku. Hope you guys had tremendous fun enjoying this video. We hope to see you soon with a video, and please do subscribe to the channel now. We'd really appreciate if you hit the subscribe button. Thanks for watching.